My name is Genevieve. I'm going to teach you a physics problem. Please excuse the very loud dryer in the background. I'm going to try and speak loudly. So what I've done is I've drawn a picture to represent the problem, because that's what you should do in physics. You draw pictures so that you can understand things better. We're going to pretend like this picture wasn't already drawn in the book. And like we're reading it for the very first time. No, computer, don't go to sleep. The question is, 3 balls are launched simultaneously, as in the figure. It's a beautiful drawing right here. The red ball is launched at an initial velocity, v0, to this guy, the one that has the arc, directed at an angle theta, which I labeled theta, because that's what you should do. The blue ball is launched vertically with a speed of 11.6 meters per second, which I noted here. So it is going only in the y direction. The yellow/orange ball is launched horizontally with a speed of 4.8 meters per second. So I labeled this, and it is only going in the x direction because it is said that it is launched horizontally. And there's no y. The blue and red balls, so these two, reach identical maximum heights and return to the ground at the same time. So they both reach their highest point at the very same time, and they also come back down and hit the floor at the same time. The red ball returns to the ground to meet the orange ball at the same place along the horizontal. So they both meet at the x-axis right here. Trying to find launch speed, so basically the initial velocity, and the launch angle for the red ball. Launch angle. The orange ball is going only in the x direction, but it is meeting up with the red ball at the same time when it hits the ground. And the red ball is meeting up with the blue ball at the same time at their max height and when they hit the ground. So first step is to notice that, so that you don't spend 40 minutes trying to go through formulas that don't work, and trying to find variables that you don't need to find. I'm not saying that I did that. So you're going to list your known variables to first find v0 of the red ball. And our variables are v0y equals 11.6 meters per second, and v0x equals 4.8 meters per second. Because of the fact that they hit the ground at the same time, they reach the maximum height at the same time, we can assume that for the red ball, its initial velocity of y is 11.6, and we can assume that its initial velocity in the x direction is 4.8 meters per second. And that will save you a lot of pain. You just realize that right off the bat, because this actually becomes a very short problem. So now that we got y, we got x, we're going to think of it as a triangle. Over here. Maybe I should write over here. We're essentially looking for the hypotenuse. Because we have this leg and this leg, you just use the Pythagorean theorem, and we're just going to skip right to the square root of 11.6 squared plus 4.8 squared, and find that when you plug this in to a calculator, or you do it in your head if you're some kind of genius, you get 12.5 meters per second. Initial velocity, or v0, is 12.5 meters per second. And then if we want to find the angle of this, we're going to use cosine theta, because when we're referring to the angle that is below the given line. we're going to use cosine theta. And above, we'll use sine theta. That would be my cat and my other cat fighting. No worries. They play nice sometimes. So, V naught x, which is our x direction velocity over here, is equal to this leg of this arm, this ray. The trajectory of the red ball is 12.5 meters per second. This is where we're going to put 12.5 cosine theta. And plug in our actual number that we had for V naught x, which was 4.8. Then 12.5 cosine theta. And you're going to do your math like you should. Get rid of that guy on that side. And then essentially you will be left with, oh, and cosine. You got to get cosine on the other side, so you got to do inverse cosine. Wait, I already put the, there we go, wrong way. On that side to get rid of that one. So now we have, well, I just apparently jumped straight to 4.8 divided by 12.5 is 0.384 inverse cosine. It's equal to theta, now that we have singled it out. And if you plug that into your calculator, you're going to get 67.42 degrees for that angle. The end.